Welcome in Arzul Technical Campus, Faculty of Engineering and MBA. Today, myself, Professor Jyoti Dhande, in Power Electronic lecture, we represent the specification of today's point is specification of SCR. This specification is also called as ratings of SCR. Ratings of SCR. Now, this specification or ratings of SCR classified into two categories. First category is current specification, or we can say that current ratings, and second one is voltage rating. Now, see one by one. First of all, we learn the current rating. First of all, we learn the current rating. See, first current rating is average current rating. Average current rating. Average current rating. Now I will explain the average current rating. It is nothing but the average current of SCR that can safely carry repeatedly without exceeding the junction temperature. Means junction temperature is specified or given in a specific limit where, and this can be carried by SCR without exceeding its limit. Constant power dissipation is controlled by average current rating of SCR. And also this average current rating, it will totally depend on case temperature, conduction angle and shape of current. Case temperature means your temperature values. Conduction angle means we learn two types of the angle, that is firing angle and conduction angle. Out of that, conduction angle is nothing but the value or the angle at which SCR remains in the on state. Then shape of the current, it may be sine wave, it may be in sine wave shape, in rectangular shape, and etc. are the types of the shape or the shape of the current waveform. And your average current rating depends on these three values. Now, next current rating is RMS current rating. Now see, what is the RMS current rating? This RMS current rating is the power loss and heating of SCR depend on the RMS value of the SCR current. Means we, in other words, we can say that this RMS value will decide the power loss or heating loss takes place in the SCR. This RMS and average current are identical for DC, that is direct current, and it will be different for the AC, that is alternating current. Now, third one is surge current rating. Third one is surge current rating. Now see, what is the surge current rating? This surge current rating indicates the maximum possible non-repetitive, or we can say that maximum possible surge current which the device can withstand without damaging itself. Means when this current is flowing through the SCR, it is the maximum value of the current flowing through the SCR without damaging it. Now this SCR can be subjected to the surge current rating only once in its lifetime, because when it exceeds its temperature, then SCR gets damaged. Hence we can say that it is used only once in its lifetime. Next rating is, fourth one is I square T rating. I square T rating. Now, what indicates this I square T? I square T is nothing but your energy. As we know, the formula for power, that is, power is nothing but V into I, that is voltage into current, and your energy is nothing but power into time. Means we can say that this I square T rating is nothing but energy rating. one is di by dt rating. This indicates the maximum tolerable rate of rise of anode current, because d by dt is denote the variations in the currents, because I, that is current varying with the time, means it indicates the maximum tolerable rate of rise of anode current. Now next rating are voltage rating. Next ratings are voltage ratings. Voltage ratings. Now see, in voltage rating, first voltage rating is peak offset blocking voltage. Peak offset blocking voltage. Peak offset blocking voltage. This is the first type of voltage rating. Now, this peak offset blocking voltage is denoted by VDRM. VDRM. This is the short form for this. Now see what happens in peak offset blocking voltage. In this case, SCR will remain in an off state if its peak offset voltage rating is not exceeded. And when it is exceeded, then it goes in on condition, or we can say that it gets turned on. This exceeding voltage may turn on the SCR, means when its limit is given, up to this limit it remains in the off state, and after this value or after exceeding its limit, it goes in on condition. Now second voltage rating is peak positive anode voltage. Second is peak positive anode voltage. Peak positive anode voltage. This is also called as a PFV. Peak positive anode voltage. Now this, see here, in peak positive anode voltage, these ratings usually above the VDRM rating. VDRM rating means which rating? VDRM rating is nothing but your peak offset blocking voltage, which learned that is the first voltage rating called as a VDRM. And this rating means your second rating, that is PFV, peak positive anode voltage, is usually above this rating, means above VDRM rating. And it is the maximum positive voltage that can be applied between anode to cathode without damaging SCR. Means in other words, when we learn the characteristics of SCR, where we see that is the breakover voltage. Now what is the concept of breakover voltage? Breakover voltage is nothing but your applied voltage is smaller than this breakover voltage, then your SCR is off condition. And when your applied voltage reach to breakover voltage, then your SCR goes in on condition, or it gets turned off. Means this is the maximum value, or without applying gate pulse, the voltage applied between anode to cathode, that the maximum value we can apply without damaging the SCR. This is nothing but your peak positive anode voltage. And if the voltage is higher than PFV, that is the peak positive anode voltage, then your SCR will be turned on and get damaged accidentally. Now, third is on-state voltage drop. Third rating is on-state voltage drop. On-state voltage drop. In this on-state voltage drop, what happens? The voltage drop across the SCR, when it is in on-state, its name itself indicates that when your SCR is in one is forward dV by dt voltage rating. Forward dV by dt voltage rating. Now dV by dt again we see there di by dt. Di by dt means what? The anode current change with respect to time. Here same dV by dt indicates here voltage is anode current is replaced by voltage, means change in voltage with respect to time. Now it is the maximum rate of rise of anode to cathode voltage that will not turn on the SCR without gate terminal open. Means whenever your gate supply or gate pulse is not applied, not given, up to that time you can apply the voltage between anode to cathode, but it does not turn on the SCR. And if dV by dt is greater than certain limit, means its specified limit, we can say that breakout voltage. In other words, we can say that breakout voltage. When it exceeds its limit, the SCR gate turned on without gate terminal. This is called as a forward static dV by dt rating. Here gate terminal is open, means no gate current is applied. SCR is totally turned on the voltage applied between anode to cathode. And now next rating is dynamic dV by dt rating. Fifth one is dynamic dV by dt rating. Dynamic dV by dt rating. Now it is greater than static dV by dt rating. First of all, we learned forward dV by dt rating. This forward dV by dt rating is also called as a static dV by dt rating. Now the question arises, what is the difference between static and dynamic? There static means what? Does not vary with time. These characteristics are the statics. And the dynamic means what? Your characteristics vary with time, then these are the dynamic. Same concept is applied for the rating purpose. When your ratings does not vary with time, then this rating is called as a static rating. And when your ratings vary with time, then called as a dynamic rating. Now, first we learn forward dV by dt rating. This forward dV by dt ratings also called as a static rating. Now, the second one is dynamic dV by dt rating. That is the fifth one, last point, dynamic dV by dt rating. These are always higher than static dV by dt rating. It is defined as dynamic dV by dt rating is defined as maximum allowable rate of rise of voltage which will not cause the failure of commutation and will not turn on the SCR when it is being turned off. This is called as a dynamic dV by dt rating. These are the ratings of SCR. Where why we learn this point? It is also important. These ratings, when we goes in market for taking the SCR or purchasing the SCR, at that time ratings is the very important point, because whenever we have to purchase any component, at that time we first of all we see its rating as well as cost, because how it works and where we have to use, these totally depend on the rating of the component. Hence, for learning the SCR, your current rating and voltage rating is very important point. Now, summarize once again. The current ratings are, first is your average current rating, second is RMS current rating, third is surge current rating, fourth is I2T rating, and fifth one is VI by VT rating. Now, summarize your voltage rating. First is peak offset blocking voltage. Second is peak positive anode voltage. Third is on-state voltage drop. Fourth is forward dV by dt rating. And fifth one, the dynamic dV by dt rating. This forward dV by dt rating also called as a static dV by dt rating. Thank you guys.